All right, I have an object sitting on a 15-degree ramp without slipping. What is the coefficient of static friction that allows this to take place? All right, so let's draw a diagram to show us what's going on here. This is my ramp, this is my object, and I know that this object is sitting there and is not slipping. So that means that it is not accelerating, which means that there is no net force. So just to remind myself, because I'm going to need this later on, I know that this scenario dictates a net force of exactly 0 newtons. So all of the forces should cancel out. That is going to become really, really helpful for me in a little bit. Now, this object is going to have a force of gravity pointing straight down, a normal reaction force that is pointing perpendicular to the surface, and a force of friction preventing it from sliding. So a force of friction pointing up the ramp in this case. I know that all of these forces should cancel out, but because of this force of gravity going down like this, it's really hard to actually see anything canceling because they are not in the same axes. So I am going to split this up into a force that is perpendicular, F perpendicular, and a force that is parallel, F parallel. All right, that forms a triangle that has an angle in common with this 15-degree angle that we started with here. So I can redraw that triangle over here. Looks something like this. This is FG. This is F perpendicular. And this is F parallel. The right angle here is the one between F perpendicular and F parallel. And this angle here is the same as the angle that we found the ramp to be. So that is 15 degrees. That means I can find an equation to solve for F perpendicular and F parallel. And then ultimately work my way through that. So I'm going to redraw my free body diagram just to include these 4 forces that are either parallel or perpendicular to each other. So I have this here where I've got R pointing up. I've got force of friction here. I've got F perpendicular. And I have F parallel. All right, I know that all of these forces should cancel each other out. So that tells me that R should be equal to F perpendicular, and that FF, the force of friction, should be equal to F parallel, because all of these forces should be equal and opposite to the force on the other side in order for my net force to give me 0. What that means is now I can look back at what I'm looking for, the coefficient of static friction. So that is associated with my force of friction. If I know FF, use a color I haven't used before. See, I've used most of the colors. If I know FF, the force of friction, that's going to be equal to mu times R. So if I want to find mu, that's just going to be FF divided by R. FF divided by R is going to be the same thing as saying the parallel force, F parallel, divided by the perpendicular force, F perpendicular, because those are equivalent according to our free body diagram here. All right, let's use our triangle and solve for what we can. We know that F perpendicular is going to be equal to force of gravity times the cosine of 15 degrees, because the cosine is the one that goes with the adjacent side, and that is F perpendicular. F parallel then is Fg times the sine of 15. which means that if I plug this in, I don't actually need to know mass. I could combine or simplify this further and say Fg is just mass times gravity. But if I take these values here and this equation that I just found, I can say that mu is equal to the parallel force, Fg divided by, or times sine of 15, divided by the perpendicular force, Fg times the cosine of 15. Notice that Fg is on both sides of this equation, so I'm left with just the sine of 15 divided by the cosine of 15, which gives me a coefficient of static friction of 0.268. Coefficient of static friction is a unitless number, so I know that that is the value for me.